Hi guys, I haven't made a video in a while. I think the last one was quite a few months ago. And right now I want to do this video about solar BMS, the new solar BMS, and I will try to go through the built-in menu of the solar BMS and explain all the functionality of the solar BMS. I hope I will not go too much out of track, and I will keep this video as short as possible, but I'm sure it will not be a very short video. Okay, so yeah, this is the solar BMS right here. I sent all of them, so you should receive them shortly. Some of you already received solar BMS, those that I sent a few of them, I think 2 weeks ago or something, and some of you already received it. So sorry this video is a bit late for you, but I will start with what you will do when you receive this. All you will find in the box is this solar BMS, and you will find a cable like this, and that's it. There will be nothing else in the box, no manual or anything else. So of course I made some description of what you should do when you receive it on Kickstarter and on my Google Plus page, but I will recap that very shortly in this video, at the beginning of this video. So what you will need is a micro USB cable. Sorry, I don't think this will focus, but most of the modern cell phones and tablets have one of these. So this is all you need, and you can plug it in a computer or in a power bank like this one. Any 5-volt power supply will work, because this only uses about 100 milliamps or something. So okay, so you have the 4 power connectors on this side, then the 10-pin monitoring connector on this side, and you also have the 20-pin, not sure you can see, no, 20-pin connector for all kind of external automation or external current measurement, or I will explain what you can do with this connector also. So yeah, there is nothing else on any other side, just this side where you have the USB connector. So when you receive it, you will plug it in on USB. You'll get some errors because of course this will supply only the LCD and the microcontroller, the interseal chip inside here that takes care of battery. It doesn't get any power, so of course you'll get some errors. And of course there is no battery connected, so no battery indication. You will see just this USB power. Let me go a bit closer. Okay, I hope you will be able to see the screen. I'm trying to do this video in natural light, but right now it's snowing. I hope the sun will not come up and mess with white color balance and everything else. But yeah, so that's what you do. You power this over a USB and then go to manual and install menu, and there you have install instruction and manual specification. So you should read this install instruction, where you have about I think 8 steps, yeah. And you should definitely read this before installing the solar BMS. And you can also read this basic manual. Maybe it's not as important as the install instruction at the beginning, but you should give it a read, and maybe you'll find some interesting aspects about the solar BMS that you didn't know, and I will try to do a PDF manual later with more details. Than this is just the basic manual. There's not much in here, but I try to include the most asked questions about solar BMS. And so this is all you can do over USB. It's nothing. You can play with the menus, but not everything is working when it's powered by USB only. So I will show you now what you do when you connect this. I have here a supercapacitor bank. I still have a few of these available if you want to get one, but this is just useful for if you want to play with a solar BMS. It doesn't store too much energy, so it's not very useful. I just made this today, and I will ship this to Martin so he can do a review on the solar BMS. So I will send him this SBMS here and this capacitor bank. And yeah, what you will do, what you will have is probably 8 or 4, depending if you want 12 or 24 volt system, 4 or 8 lithium iron phosphate batteries. So what I have here is 8 supercapacitors. That's 220 farad at 2.5 volt. But it's not very relevant. So and I use this kind of stuff to test the solar BMS because I can charge this in and discharge them in a few seconds or minutes at most. So I can easily do tests. And then you see this connector. You have the black and white wires connected to the ground of the battery, to the negative terminal. So and then starting from the gray colored wire, this is for cell 1, or in this case a supercapacitor 1, and then all the way to the last one, which is connected to the battery positive terminal, and that one is I don't know, sort of brown or something like that, the darkest red color in there. And yeah, I can't say much more about this. These power terminals are also the positive from the supercapacitor bank, or in your case battery bank, and the negative. So I don't think I can say much more about this. But this is what I will use right now and to demonstrate this solar BMS. And so this is what you will connect first is the high power. This is just an AWG18, I think, or something, but this is for test, so you'll have a much thicker cable. You should check, I have done a Google Plus post about cables and what sort of cables I recommend for solar BMS. It's a silicone insulated cable that can withstand 200 degrees Celsius, and it's extremely flexible because it has I think 3200 very tiny wires, and so you should check that post. I will put a link in the video description to check that. But that is a really nice wire, and you will need a flexible wire. You should not connect a solid wire or one that is very rigid, because you can damage the power connectors. These are SMD soldered on a aluminum a metal core PCB, and you will put a lot of stress on the joints. So you should use a flexible wire, and try not to have the wire, all the weight of the wire pulling on the connector if possible, because you should also take care about the amount of force, the torque you put on these connectors, because you will be using something like this 4mm Allen key, and there will be you can damage these connectors because you have a lot of force when you use this type of tool. So please be careful, don't damage these power connectors, because the repair will not be easy. Okay, and so this is the first wire that you connect. This is the positive from the battery, the positive terminal, and you will be connecting that here at the battery plus. And yeah, this is a very tiny wire. It's not good for this type of large connectors. You will not have. I'll try to. Okay, now it's good. Okay, and the next thing that you will be connecting is the 10-pin connector, after you, of course, connected the other end to the appropriate cells. And I will show you, if you have 8 cells, it's simple, you will use all these wires, but if you have maybe only 4 cells for 12-volt battery, or other configuration, because you can use any number of cells, from starting with 3 cells, this minimum, and maximum 8 cells. So I will show you in the menu the diagram and how you will be connecting this to your battery. But for now, let's power this solar BMS, and you see now you don't get any errors, and it will go through some calibrations. So now it's powered on, and the first thing you will do is to go to parameter settings, the second menu, and select the type of battery that you will be using. Most likely the type 1, which is lithium iron phosphate. And the next thing you need to do is select the number of cells. By default it's 8 cells, but if you have 4 cells, for example, you see the circuit diagram on the bottom will show you what sort of connection you need to make and how to connect those 10 wires to your battery. Not sure you can see the LCD very well, but yeah, this is the circuit diagram. So in this case, the pin 1 and 2, which is a black and white wire, will go to the negative terminal of the battery. And so, or it's the same with the negative terminal of the first cell. And then you have the gray and the purple wire connected. And then all the other wires that are not used from there, like the blue, green, yellow, and that orange wire, all those will be connected in the same point between the cell 2 and 3. It's marked as cell 7 here because it's actually cell 7 if you ask the interseal chip. Is this the way the cells are connected has to do with how the interseal chip is made or designed internally. So this cannot be changed. But yeah, I hope this diagram is easy enough to read and understand. So this should be all. And like you see, you can use from 3 up to any number of cells. Maybe you will use 7 cells if you use other type of lithium cells, those that charge usually at 4.2 volt, to have 24 volt compatibility. Okay, so And next you need to introduce your battery capacity. So I don't know, let's say you have a 100 amp hour battery, then you just select here 100 amp hour and push OK. And this is all you need to set. If you don't want to mess with other advanced settings, this will be all. And what you do, you will just push this button, and all this will be stored in the intercell chip. And after you do that, you need to remove the 10-pin connector and then reinsert, and all these new settings will be then the current settings. But of course I don't have a 4-cell lithium iron phosphate right now, so I will go back to the supercapacitor settings, and I will leave everything as default, because this is exactly the data for the supercapacitors, and I will brought this data back into the intercell chip. All this data will be saved inside an EEPROM type memory in the intercell chip, but it will only take effect after you remove the power from the intercell chip and then reinsert the 10-pin connector. But nothing else should be connected on PV or load while you remove this connector. So you should never remove this connector if you have anything else except for the battery positive wiring here. Else you damage the solar BMS, maybe even the load or something else, because the solar BMS will be floating. The only negative terminal he can get is from these two wires, and so if this is not inserted, then you don't get, then the solar BMS will not be powered. But if you have a load or something, it can draw maybe a bit of current through the load, something like that, and that will not be good. It will probably damage the solar BMS, and who knows, maybe the load, depending on how sensitive that is to voltage drop and this kind of stuff. So don't do that. And okay, so I inserted this back again. It will, when it powers on, it will do the offset calibration for the ADC, the current part of the ADC. The voltage is measured by the intercell, but the current on PV1, PV2 and battery is measured by the microcontroller, and internal 16-bit ADC, it's will need to be offset. Okay, so that's it. After you did this and everything works fine, then you can start to connect your PV panels and load. So, but before you do that, you need to go to page 3 in the monitoring menu. Push OK, so you will get an pop-up menu, and then select load off and push again, OK again, and then you see the charge FET and discharge FET are now disconnected, because you will not want to connect your solar panel when the charge FET and discharge FET are connected, because then you will get sparks and you will damage the power connectors. Okay, so I will be using this sort of constant current, constant voltage power supply, which will simulate an solar panel. So or a charger. You can use any type of constant current charger, as long as the current doesn't exceed the capabilities of the solar BMS 60 or 100, depending on what are you using. So the negative from the solar panel, let's call it solar panel for now, will be connected to the negative of the battery. So this will be connected together, and then the positive of the solar panel will be connected. I'll connect it here to PV2 in this case. Okay, and then you should push OK again and connect the PV and load. But if you also want to connect the load in here, let me connect also the load. I have some old and not very great LEDs that I will connect as a load. So again, what I'm doing now you don't see because it's off camera, but I connect the negative of the load to the battery negative terminal. All those negative from PV, from battery and from load are connected together in one point. Okay, and now I have this is the positive from my load, so I will try to connect that. It's also very tiny wires. I think it's AWG22 or something. Okay, and now I push on, and then both the load, I don't know if you noticed some additional light from those LEDs, and so-called solar panel is working, and as you can see, it starts charging. The load is using about 700 milliamps, and solar panel is putting in 1.9 in this case amps. So 1.16 is going into battery, and what you see here in this side is the cell balancing at work, because yeah, this is a new set of supercapacitors, and I think this I only charged them like 20 minutes before starting this video first time, and now they are not quite balanced, but the cell balancing will do that in a few cycles, no problem. Okay, and yeah, this is all about how to connect the solar BMS to your battery, to your load, to your solar panels. So, but all this is written in the install instructions, so if you read that, you should be fine. But yeah, I wanted to show in this video also this part. And now I should show you the menu and how it works. I mean, this is the first one, is the monitoring part, and I should probably remove the load because I don't know if you can see the screen with this additional LED light. And of course, when you remove it, you should also power off first the FETs, so you don't damage them. And I think I can also remove the so-called solar panel, so that it's easier for me to work here. Okay, now you see when you push OK button, you usually get an additional menu in most cases in the monitoring system. So in here you get an option for current or power to be displayed. So if I select power, you see all measurements are in watt, and if I select current, then it's in amps. So what else you have in here? You have the total battery voltage, the delta between the highest and the lowest cell. You have the battery current, PV2, PV1 current, the sum of the PV1 and PV2 current, and then the load plus external load. I will explain what's with the external load current in here. And then you have the internal temperature. I don't think it's 26 degrees inside the room, but probably because I had my hands on the solar BMS, I heated the power board a little bit. So there is a thermistor on the power board that measures the power board temperature, and if this exceeds 60 degrees Celsius, then it will shut down automatically the PV, the charging and discharging. So to protect itself, if it can do that, if the MOSFETs are, I don't know, faulty, like short-circuited, then of course it can try, but it will not manage to do anything. So and this other one, ET, is the external temperature, and there is no sensor, so you see minus 45 degrees Celsius because there is no external thermistor. And then you have the cell voltages in a numeric format and also in a graphic format in this other side. So this first page of the monitoring is probably where you will spend most of the time, or I don't know. This is what I usually use, this first monitoring page. And then you have the next one, which is the accumulated energy. Like you see, we put 1.1 watt hour in the supercapacitors. That's about the usable energy stored in this type of capacitor. It's not much more. And then what you can do here, again, with the OK button, you have the option to delete, to reset these counters. So let's say we reset the load counter separately. So you see now it's 0. It was, I think, 0.5 watt hour. Or you can reset all at once if you go and select the last option. So now everything gets reset here. And then next, you already seen this. These are what I call error flags. So SBMS can detect most of the problems or faults, and it will display in here if that's the case. I mean, not everything is an error in here, but like charge FET and discharge FET are highlighted now to show that they are on, active. But also when you'll see this over voltage condition, it's when the battery is fully charged, and it will disconnect the charge FET and it will say that it's an over voltage on one of the cells, but that's a normal operation. It's an over voltage because the cell reached, in case of lithium iron phosphate, 3.55 volt, and then it will stop the charging. So, but it's not an actual error. And the same with the under voltage, when the battery is fully discharged, one of the cells is below 2.8 volt in case of lithium iron phosphate, and you will see this under voltage error message, but it's not critical like some other, like I don't know, short circuit or discharge short circuit or charge over current or things like this. These are a bit more critical. It means something is wrong. But and this one in the middle, end of charge, will also be often highlighted, because I think you even seen this when I charged before, if I remember correctly. Yeah, that's it about this. And oh, sorry, there is another menu in the monitoring. This is the graph, the energy graph. So you have 9 mini graphs in here that shows the PV1 and PV2 current, the battery current, and the load and external load current on the bottom. And the first part of the graph, it's the last minute, and the second one is last hour, and the larger one is the last 12 hours. But you can zoom in on any of these 9 graphs by pushing the OK. You get a menu. Again, you can see current graphs or power graphs, and you can select one of these 3, PV, battery or load, that you want to zoom in. let's say we select PV, and then you see the last 4 minutes in here, but you can then push again OK button, and you can select the last 4 hours. You see it's a peak of 1.9 amps in here. If you remember, we charged at 1.9 amps. And of course you also have a cursor that you can move with the up and down keys, and you can go into more details and analyze the energy graph. And you see in this case you have 0.8 amps at about 6 minutes ago. So yeah, you can use that, but the screen is quite small. You probably only do this if you really want to investigate some problems, some faults, or you want to see what was the peak power for the day or something like that. And of course you can select the last 24 hours, but yeah, it's not much in here because I just powered this on. Okay, and you see here the peak, it's just 759 milliamps. That's because it makes an average in the 24-hour graph. It makes an average for the last for each 6 minutes, and in the 4-hour graph it's an average for each minute. So the average current for 1 minute, it's stored in this graph, so to correctly represent the energy that it was used. And again, the same for battery. You have with green it's charge, and with red it's discharge. And and for the load it's the same. You have two energy graphs in this, because you have the external load, which is separated with a different color, and the internal load, which is the load on this power connector. Okay, and yeah, that's it. I think you can play with this and find out more. And then the next menu, it's parameter settings. I already discussed about this. If you don't know much about the batteries and you don't want to mess with advanced settings, all you need to do is this 3 very easy settings. The type of battery, probably number 1, and then number of cells, again maybe 8 if you want to use 24 volt, or 4 if you use a 12 volt system, and then battery capacity, and that's it. And the store parameters, reset, and I explained at the beginning of the video. And then for those that want to tweak the other parameters that were also available in the older SBMS model, you can do so by going into this advanced menu, and then here you have the same 3 parameters that are important, but then also you can go and change, like in this case over voltage it's 2.5 volt, because this is a 2.5 volt super capacitors that I'm using. And you can change all these parameters, but I will not go into details on what each of these parameters means and what it does. You can watch I have an older YouTube video about SBMS 4080. I don't know exactly how it's called, but you'll find it. It's SBMS 40 menu system or something like that. It's a 1 hour long video, and then I go in more details about each of these parameters in there. But you also, when you stop on any of these settings, you will get a scroll in help that will explain what each of these parameters actually do. If it's not clear from just the name of the parameter, then you'll get a bit more explanations in the scroll in help that is available everywhere in the menu, not just here in advanced parameter settings. So if you wait a few seconds, there will be a scrolling text everywhere, even here outside. Okay, and what you can do, like say you change the battery type in here to 1, okay, and go in advanced parameter setting, you already have this setting here with the default values, so you don't need to change them. But after you change something in here, you can go at the end of the list where the same store parameter buttons is available. You can use back button and use the store parameters in here. So as long as you don't completely get out of this menu, then the settings you make are not lost by pushing the back button. So if you make changes in here, like say change this to 2.46, and then go back and then go on this button, it will save the settings because it remains. But if you go completely out of this menu, then when you enter this menu first time, it will read the actual parameter set inside the intersil at this time. So everything that you change here will be reset if you get out completely of this menu. But yeah, I will not say anything more about this because I think it's quite easy now with this simple parameter setting. Just 3 things that you need to change, and in most cases this will work great. So you don't need to go and mess with advanced settings. And then on the device settings, you have time and date. If you look here on the bottom of the screen, not sure you will see on camera, but there is a mem symbol under the Wi-Fi symbol, and that one it's not active at the moment, meaning that there will be no internal data logging done at this point. In order to start that, you need to set a date and time. So when you go here and you set the date and time, just set some bogus date in here, and then select the year, okay, and set. Then when you get out of this, after you set all the time and date, I think you can see now there is a mem symbol highlighted now, and that means that now internal data logging is active, and it will remain active all the time. And internally the Solar BMS has an 128 megabit flash memory, which is about 16 megabyte of flash, and it will data log each 2 minutes. So each 2 minutes it will take the average of current and the voltages and everything. It will store those in the internal memory. And internal memory has a capacity of 1 year. So you always have the last year inside the Solar BMS. And I will explain how you download those data later. And then you have the LCD and touchscreen menu, and from here you can change the backlight level from 1. You probably don't see anything, but because it's quite a lot of light in here, but you will see something if it's in a dark room. And 25 it's a default, and then 32 it's a maximum brightness. There is a special IC that controls the LCD backlight that I introduced here, and it's not a PVM, it's an analog current limiting control for the LED, so it will not flicker on camera or anything. And then I think I can leave it at 32, no problem. Maybe you can see it better now. And then you can change the menu color. By default it's the number 2. There are 10 different color schemes that you can select from, and I don't know, let's select number 9, maybe blue, it's more visible on the camera. So you can select all sort of current schemes that if you don't prefer the default one. So then you have the backlight timeout. This is set at 5 minutes by default, but you can set it at any level. And what happens here when this time will elapse, so in 5 minutes, if you don't touch any of the buttons, then the backlight level will drop to level 5, which is in the dark room, or it's still visible, quite visible, but it's to save a bit of energy. It's not much, it's really, I think it's like 1 milliamp at level 5 for the LEDs. But is to preserve the life of the LEDs. I mean, these LEDs need to last for 25 years or more, 30 years, 50 years. I designed this to last at least as long as solar panels. So, and a good lithium-ion phosphate should last also about 20, even 25 years. So of course this should also last as long. But then and you have a key lockout. So if I reduce this to, let's say, 1 minute, and I will not touch the keys for 1 minute, then the keys will lock out, meaning that it's like on a cell phone, so you don't push by mistake buttons and or get some I don't know, maybe there is these are quite sensitive and should not be influenced by anything other than your fingers, not water or something else. But of course this is not waterproof, you should have this indoors only. But I just introduced this key lock just in case key respond to who knows what. I never had any problem with the keys to respond to something else than a real touch from a human finger, but who knows. So just as a safety precaution, I use that. And then you have the UART setting. You see that now the baud rate is quite high at almost 1 megabyte per second, but megabit per second. But that's because now it's the UART, the serial port, is used by the Wi-Fi module, and UART is off. You see it's 0. If I put that to 1, then it will power off the Wi-Fi and select the serial interface as the main data port. But next is the Wi-Fi, and as you can see, 1 means that it's on. The best way to save power, this solar BMS uses around 600-700 milliwatt at maximum with Wi-Fi on, LCD backlight at full and everything. But the thing that uses the most is the Wi-Fi module. So if you turn that off, then you reduce the power consumption to about half. Anyway, it's insignificant even with Wi-Fi on for a large battery in a solar setup. So even, I don't know, a 5-watt solar panel that is somewhere outside, even in the shadow, will be able to produce enough energy to power the solar BMS. So it's not a problem. I don't say you should turn off the Wi-Fi, but it's just a remark. If you want to save power for whatever reason, then the best way is to turn off the Wi-Fi. Okay, and because it will be turned on not in software, in hardware, so the power will be cut to the Wi-Fi module. And then you can select the Wi-Fi channel manually if you want. You can, if you have more than one solar BMS, you can change the name of one of them. Like this will appear as an access point, and the name of the access point will be SBMS -100. But you can change it to 101 or whatever else you want. So you can use up to 100 of this if you want, with different Wi-Fi names, access point names. Okay, then this is if you want or not to use a password. So if you set this to 1, then it will use a password. By default, I don't use any password because I don't see it necessary, but you can use a password and you can set the password in here. So it's split in 2 parts, so it's easier to set, because as you see, you only have up and down keys and just 5 keys in here. You cannot write a complex password, but it's you have like 5 characters in here, just numeric, and then another 5, and then 3 letters BMS at the end. So this should be good enough. And here is the status. So if you don't see anything here, it means something is wrong. The Wi-Fi doesn't work or something. Of course, when the Wi-Fi is on. So this is just a response from the Wi-Fi module when you send all this data. So I don't think I need to say anything about the Wi-Fi module. And then I was just talking about internal data logging. And in here you have, you can select the amount you want to download. So like January, February, March. And then after you select that, you can push this start download button. But before you do that, so you enter this menu, you select amount, and then you are prepared to push this button. But first you need to go to the your cell phone or tablet or whatever you use, a computer to download the data to. And then you will need to write 192.168.4 and 1. It is the IP of the page with dot, of course. It's 192.168.4.1, and that's the IP address of the Wi-Fi module. I left the default one, so I didn't want to change it to confuse people that are used with the ESP Wi-Fi module. They know that that's the default IP that you, and then you just push this button after you open you connect with your device to the SBMS100 or 60 or whatever, and then you open a web browser, write that IP that I just told you about in the web browser address bar, and then push enter. The web browser will wait for some data, and then you push this button and all the data will be transferred to that page, and you just save that page as a text file somewhere on your computer. And for now, all the data it's compressed, and I will make a software to decompress those data and even display them, probably something that works in a web browser, so it can be used on any platform. But I didn't have time for that, but I will do that later. So and now you see the keys are locked. So in order to unlock, you need to push the OK, up and down key. So now it's unlocked, and let's increase the time here to, I don't know, so I don't get bothered by this. Okay, and I think it's too much light in now. I should reduce this because it's snowy outside and it's already getting late, so it's not enough natural light in here. Okay, and I don't want to have this look too bright to the camera. Okay, and now what else? Internet data log. Okay, so you have save device settings and factory reset. these two are buttons. So save device settings, what that means is that it will save everything that it's in here, not time and date, but LCD and touch state settings, UART, Wi-Fi, all these settings will be saved, and also the settings in the next menu that I will show you. So when you push this, it will save in the internal flash all these settings. So now if I remove the power, the color scheme and all the settings that I made in here about backlight level and everything will remain default when you power again this. But of course in real life you will not do that. I mean, you will not power off and on this. You probably install this in your off-grid home, and then it will stay like this without any reset for 25 years, hopefully, or maybe 20 if you need to change the battery. And then you have factory reset, so in case you, I don't know, you did some settings in here and you are not sure about, you can do a factory reset. But when you push the factory reset, it asks for confirmation, so that you cannot push this from by mistake. So first press OK to confirm, and then press OK again, and then it will reset all those settings. And now when I power on and off, it will be again as it was on default state. Okay, and what else? Automation. Okay, so you have here the, I hope you can see, try to get this closer, because it's a small text, so I don't know, probably in HD you will be able to see this. You have the pinout of all these pins on the 20-pin connector. And so the first two are UART, so it's the serial port that you probably will not want to use because it's used by the Wi-Fi. So if you want to use the Wi-Fi, you cannot use this. And then the next two, pin 3 and 4, those are reserved for my next project, because I will have, some of you know, I will build something similar with this in size and everything, but it will support 7.5 kilowatt of solar PV and will be used for heating. So it's a sort of solar PV heating with digital MPPT. This is it's a very long name, and but I don't have a shorter one for now. I will need to think about that. But that will be my next project, and these two pins are I2C, an I2C interface that will communicate with that device. So for now, it's better not to use these pins. And then, yeah, I don't want to spend too much time explaining all these pins, but let me see what's important in here. You have the external I/O 2, 5, 6, 3, 4, 5, and 6. This you can use if you go in this menu. So those that had the 4080 already know about this. There was something similar, not, you didn't have so many pins, but very similar, where you can have these logic pins indicate that charging is done, or discharging is done, or if you want to indicate that battery state of charge is at 90% of or 30%, you can do that by selecting the type of this pin. And if you wait for the scrolling text, you will see what every type that you can select in here will do. So yeah, this to automate some stuff, and you will actually need to use one of these pins if you want to have an external load, like a very large inverter is possible. And you will have a current shunt. I don't have one to show you now, but that's just like a power resistor, that's it. and you can use one that it's up to 500 amps at 75 millivolt, meaning that when 500 amps go to that power resistor, 75 milliamps will drop on the resistor, and that voltage drop will be measured by solar BMS on the pins 15 and 16 in here. It's ADC1N and 1P. And if you look in the manual inside the solar BMS, the basic manual, I explain in quite a few details about the way you connect an external load. And so the external load can be with a 24 volt system up to 12 kilowatt of power, so 12,000 watt. That's probably more than you need. I don't think there are inverters or any type of DC loads that require more than 500 amps. So yes, and then you will need to use one of the X pins to switch off the inverter in case the battery is empty. So because the inverter will only check the total battery voltage, but one of the cells can be low, and in order to protect the battery, the solar BMS will need to have that external I/O pin, one of those 4 that I talked about, able to switch off the inverter or whatever load you have, probably an inverter. And most modern inverters have remote on-off capabilities, so you just need to look on how that inverter, usually it needs a digital signal, maybe a 0 to 5 volt or something. This is a 0 to 3.3 volt, but you will anyway use an opto-isolator between this and I will give more details about this in the next video that will be about the hardware, so I don't want to spend more time in here. So, and the other menu that is in here, it's you can have the external load on or off. If you don't have an external current shunt, then you should leave this off so that you don't get the noise of the ADC, give you some false reading on the external load that doesn't exist. And then you select external current shunt and value, and the way you do that is you divide the rating of the output voltage of the current shunt, usually it's 75 millivolt, and then divide by the current rating, and then you get a resistance value of the current shunt that you will introduce in here. This is already for a 500 watt, 500 amp and 75 millivolt current shunt. Okay, and in case there is any offset, you can manually adjust the offset of the external current shunt reading. The thing is that there are current sense amplifiers in here, and they can have positive or negative offset. So if the offset is positive, the ADC can see that, and it will auto calibrate when you power on and off the solar BMS. But if the offset is negative, then you need to add that offset in here. So and yeah, I did the same for the internal current shunts. So the internal current shunt, it's 0.33 milliohm for both PV inputs and 0.2 milliohm for the battery current shunt. And since battery current shunt, it's a bidirectional, it can measure negative and positive currents. This will make the offset calibration automatically, no matter what type of offset current sense amplifier has. So there is no problem there. But for PV1 and PV2, which measure just positive currents, and it's connected to an ADC that it's not bidirectional, then you need to add the offset if there is a very small offset. It's usually a few milliamps, maximum 200-300 milliamps, no more than that. And then you can add that offset in here, so you have much accurate current readings. Okay, and what else? Diagnostic, this is not something that you will probably be interested in, so I will not go into any details, but what you have here is the ADC readings and some other stuff related to interseal chip, but it's just this was mostly for me during development, so it's not really too important. And then I already talked about this manual and install. You should read that. And in about what you have here, it's the model number and software and hardware version. And then you have PV and battery current energy over the lifetime of the solar BMS. So each 24 hours, the amount of energy that it's measured will be saved into internal flash. So let's say you keep this for 2 years, and then for whatever reason you remove this, then all the energy counters for how much energy you received from PV 1 and 2 and how much energy you extracted from the battery will be saved. Of course, last few hours may probably be missing because this will save the data every 24 hours into internal flash. So you need to leave this running for at least 1 day to have something in here saved. So if I remove now the power, this will be lost because it's maybe an hour since I powered this on. So it didn't yet save this into flash. The flash has a limited number of writes, so I cannot write all the time to flash, and so I decided to write every 24 hours, so it will last for 20-30 years and not damage the flash memory. And yeah, that's it. It seems I'm at the end of the description. What else you have here? It's the battery capacity, numeric and graphic format, and then you also have the lower part is the load and the PV and the load, and this will not be highlighted if they are off. Like for example, if the battery is full and the PV panels are disconnected, this will not be highlighted anymore, and then when the charging starts again, it will be highlighted. So this menu button will get you back in the menu from main menu from anywhere, and also if you push this for more than a few seconds, like now, it will power off the load and PV charging. But in normal operation, you will never want to power off the load and PV because that will be done automatically when battery is fully charged or fully discharged. So normally you don't care to do that. Like if you power your off-grid house, you want to have power all the time. You will not want to power off the load because that will be powering off your entire house. So normally you don't use this button. So, and again, if you push again, it will power on. Or you can go like I showed in here and select on and off. It will do the same thing. So, and here you can see the charge and discharge FET. And so these two on the bottom here, it's the mirror of this charge and discharge FET. If they are not highlighted. Even when they are not highlighted, you can still see something in there, but not sure if that's visible in the camera or not. Anyway, yeah, that's it, I think. Yeah, I will make another video about the hardware, and I will give you more details about external load and external I/O pins and how this is made internally and all kind of other stuff. This was just explaining the menu and things like that. So yeah, it seems it's a bit over 1 hour, but it's not an extremely long video, so that's fine. I hope I didn't miss anything in here, and I went through most of the stuff. But yeah, of course I forgot something, so I will add this to the end of the video. And is the I wanted to show you the Wi-Fi and how that works. So this is just my cheap Android phone, and what you do is open a web browser. First you need to copy the HTML page that it's in here. I will put the link in the description, and so copy that, download that zip file from my website, then unzip it, take that HTML file and put it on your device, computer, phone, whatever. And in the case of Android, you cannot actually open a file from directly in the web browser. So you will need to manually write the location of the, let me try to do this. You see, you'll need to write this location file. In my case, it's on SD card and in the download folder. And the name here, it's SBMS100 new, but when you download your file, it will be called SBMS with large characters and .html. So it will be a shortened name. So you need to introduce the link here manually, unfortunately. As far as I know, I'm not a really big user of Android devices, so I'm not too familiar. Maybe there is a way to directly open from the file from a file browser, but I don't think that's possible. At least I didn't see that. So anyway, come on, let's see. So I don't know if you can see the screens. Okay, so you see it's not updating exactly very fast, maybe, or it stopped or what. No, it makes an update every 3 seconds. So let me try to add something here, like the solar panel, so-called solar panel. And I forgot to turn off the PV, you see. You heard the spark, so don't do that. You first need to power off the load and PV, and then connect the PV and then turn it on again. So, but yeah, it's not updating or what? What's wrong with the phone? Okay. Okay, so you will see the same graphs as here, but in a bit lower resolution and a bit different on the web page. And you see cell balancing. All the data that are in the monitoring are, almost all the data I think, are also present in the web browser. And yeah, these small web browsers on the phone don't always work reliably. Sometimes they stop, but it's not SBMS fault. SBMS will send data every second, so it's just that the phone browsers are not always working correctly every time. Sometimes they stop and you need to refresh. But yeah, I didn't do much tests with the phone. I usually test this on my computer where it works perfectly every time. But I cannot, it's easier for me to show you the phone on the camera. And so yeah, that's it. I wanted to show this. And of course you need to connect to Wi-Fi. And you see SBMS100 connected. So and you see some time ago I did some tests with SBMS60 and I changed here to SBMS62. So of course that's full strength Wi-Fi, because it's just 5 centimeters from the Wi-Fi module. But the range is about 30 meters, I think, from what I've seen with this phone and with the Solar BMS. So 100 feet or something like that is the usable range. It depends if it's if you have many walls and if they are made of concrete or something. But yeah, around that is the range, 30 meters, 100 feet. Okay, so let's see, this still works. Yep. I don't know why it stopped first time, but it seems to work now reliably. And then yeah, you have this save log button. Probably it's a bit small. Should use it in landscape mode. So you see there is a save log button here, and if I push that, starting downloading. So if I look here, download complete, there is a text file, you see, with the compressed data of this is all the data that were just saved during this demo, this short demo. So it's every 3 seconds you get one of these lines, and I will have a link to a small document that explains how these data are compressed and what everything means in here. But it's basically a time and date stamp. Then you have all the cell voltages, all the currents, battery and PV currents, and so on each of these lines you have all those data and the status of the Solar BMS. So yeah, I don't think I was talking about the status. You see there is a statistic number here. It's not sure you can see it, it's very small. Can you see under 84% there is what's now 16385, and this represents it's mostly for me, so I know what's the status of the Solar BMS. But you see it represents the value, the status of these 15 flags. So I can have here a number that represents that in you can consider this a binary number of 15-bit binary number, and you convert that in a decimal, and that's what is this status number in here. But it's really not very important for you, but for me it's important because maybe you will send me a screenshot of the solar BMS, and you will not be in this particular screen, but I still know what, if there is any faults or any problem with the solar BMS. So that's why I did that stat number in there. Yeah, I really hope this is all. I didn't forget anything else major. So yeah, thanks for watching again, and if you have any questions, please leave a comment. Thanks.